Okay, here we are, part 3 of this, but we're going to continue finishing number 13. We've got 2 problems left on 13, E and D. All right, so E says there are at least 3 lefties in the group. So this is kind of like a trick I like to do because it makes life so much easier. Here's what I'm going to do. I've got 5 kids that we're going to select. So I'm going to list the number of lefties that I could have. Like we did in L1 that time we were talking about J and K having kids. It's actually the exact same values. Because they could have 0 or 1 or 2 or 3 or 4 or 5 kids with type O blood. And here, if I've got 5 kids, I could have 0 or 1 or 2 or 3 or 4 or 5 kids that are left-handed. And the question says there are at least 3 lefties in the group. So what does at least 3 mean? 3 means this. I could have 3 or 4 or 5. So what I could do is I could use the binomial PDF in the calculator and find it for 3, and find it for 4, and find it for 5, and add them together. That actually would not be too hard to do. So, before we do that, however, let's talk about what you have to write. Because you have to write the binomial formula. But writing through the binomial formula 3 and 4 and 5 is not that bad. But what if you have like 20 kids? What if you have 20 kids and you're talking about the probability of having at least 8, which means you've got to do 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. And writing all that out would really stink. So here's what we're going to do. We're going to kind of cheat, but it implies that I know exactly what's going on. You're going to write the binomial formula for the first one, and the first one is 3. So I've got 5 kids with 3 successes. Probability of success is 0.13. Number of successes is 3. Probability for failure, complement of success, 0.87. Number of failures, 3 plus 2 is 5. Plus. Now I should write for 4. But I don't care about 4 because if I do actually the first one and the last one, it's obvious that I know what should be going on in between here. So I've got the first one, I'm going to do plus ... say and all these, and then I'm going to write the last one. And the last one would be 5, choose 5 successes, times 0.13 to the 5th power, 5 successes. And if I have 5 successes or 5 lefties, how many righties do I have? I have 0. So that's what I'm going to do. Now I could do this on my calculator. And actually the easiest way to do this would be to do this through the list menu. And I would go to Stat, and I would go to Edit. And I would go to like L1, and if I went to L1, I would put in here clear, and I would put, okay, what values do I need? I need 3 and 4 and 5. And then I could go to L2, and I could do second distribution binomial PDF. Binomial PDF of 5, 0.13, and where is my successes? My successes are in L1, and there we have the values that match up. And there's for 3, which we got for the binomial PDF, and 0.0012, which we got. And I didn't start this again. Man, I'm just horrible with this. And then we've got this probability of 5 kids, which is really, really small. So I've got those values there, and then I would need to sum them up. Okay, I could do that. I could write down those results, and I could sum them up. But there's an actually much easier way to do this. And here's what I want to do. I want to think about this. Here's the normal distribution. If I had a normal distribution, we've done this before. And I said, okay, say that I had a value and I wanted to find the probability of being at least that. At least that means that or more. What I could do is I could go to the table. And the table always gave me the area to the left because it was cumulative up to this point. And then I would subtract from 1, like we do with normal curve. Well, this is the exact same thing. We're not, however, going to use the table, but we are going to sit there and think, okay, what I actually have here is I've got this dividing line, and I've got a lower section, and I've got an upper section. And these 2 sections, because all the probabilities have to add up to 1, are going to be complementary to each other. So if I can find the probability of this group, then 1 minus that would be the probability of this group, just like this. This group down here is going to be complementary to this group. This group is going to be complementary to this group. So can I find this group very easily? And the answer is yes, because if we use the binomial CDF, the cumulative distribution function, it will start at 0 and then add 1 and add 2 up to the last value that you choose. And the last value that I want to include in this is 2, because what I want to find is I want to find the complement from 2 down. So I would, in the calculator, I would do binomial CDF NPR 5, 0.13, largest value I want to accumulate to, and that would be 2. So I'll do that. I'll go to the main screen, and I will go to the distribution menu, and I will find binomial CDF, and I will say, okay, binomial CDF NPR 5, 0.13, largest value I'm looking for is 2, and that value is 0.9821. Okay, 0.9821, and I want 1 minus that. Now, if you're going to do this, you need to show this, that you're doing the subtraction. 1 minus 0.9821, and I would do 1 minus the answer, and I get 0.0179. 0.0179, and there's your answer. 0.0179. Okay? Good. Now, let's take a look at the last question here for this, and there are no more than 3 lefties in the group. So again, I think I got 0, 1, or 2, or 3, or 4, or 5, and there are no more than 3, which means we're talking about that group right there. What do you have to write? I have to write the binomial formula for the first and the last. So I'd say I've got 5, choose 0, success 0.13 to the 0 power, because I've got 0 successes, times 0.87 to the 5th, plus, plus the last one, 5, choose 3, times 0.13, I've got 3 successes, 0.87 to the 2nd, and then how do I solve this group? Binomial CDF of 5, 0.13, largest value I want to go to is 3, and I would get an answer, and I'd say, oh, is that the one I want to use, or do I want to do the complement? And so, no, that's what I want to use, because this is the group I'm looking for. Final answer there, Regis, 0.9987, by the way. Okay, chapter, or number 13, lefties, done. Coming back.